I will show some improvements I've been doing with the refactorings in Cuis. Well, not me, but the students I have at the university. Are you looking at my quiz right now?
Yeah, yeah, we can see the screen.
Okay,
yes.
Cool. So the good thing about teaching at the university is that I have students to work on different things. So lately I've been, directing thesis with, implementing new refactorings and improving them. So what I'm going to show is a couple of different things that we added to Cuis lately. The first one is very simple, push-up method. You already know that. That has a different implementation in a sibling class. Here it says 11 factorial, and here it says 10 factorial. So if you push up this method, nothing amazing is going to happen. It will remove it from the subclass, add it to the superclass, and that's all. But if you have push up with existing, let me see. Yeah, I think this one. Push up existing in superclass with different implementations. So you have the same message also implemented in the superclass, but with a different implementation. It will ask you, what do you want to do? The method with different implementation already exists. Do you want to continue or not? If you say yes, it will rewrite the one in the superclass and remove the one in the subclass. Push up existing in superclass with same implementation. So let's say we have the same message implemented in the superclass with the same implementation, in this case, nothing. So if you push up this method, it won't ask you because it's the same implementation. Doesn't make any sense to ask you for that. And if you have this message implemented as a subclass responsibility in the superclass, okay, and different in the subclass, because it is a subclass responsibility in the superclass, it will not ask you. It is a different implementation, but it will not ask you if you want to replace it because it's a subclass responsibility. So it will just push up the method and change the implementation in the superclass. Those are the things we did for the push up, the push down. Now you can do, well, push down to all subclasses or to one subclass. So if you push down to all subclasses, it will put here the subclass responsibility for that message and push down that method to all subclasses. And if you select to push down to one subclass, let's say, I don't know, B, well, it will tell you that this is not a refactoring because that message is not implemented in one of the subclasses, and if you want to continue or not. Okay, it's your responsibility because this is not a refactoring. And if you say yes, it will push down that to the subclass. I think that's all for push down. Then we have a complex refactoring. I call it complex because it does many things. This is struct method object. It allows you to create a class from a method. So here we have this method, the struct method object, that receives a parameter and send a message to it and so on. So you can come here, struct method object, and it will ask you the name of the class. I don't know, structed.
Okay.
Method object, which the superclass, the category, what's the message that you're going to send to instances of that class to evaluate it, let's say value. How do you want to call the argument? But that argument, that parameter is going to be an instance variable of the new class. So let's call it, I don't know, instance variable 1. And how do you want to call the instance creation message? I don't know, with or whatever. So if you have more parameter, it will ask you for all the keywords for each parameter. If you do the refactor, so it will instantiate that class, send the message with the parameter, and then the message value to it. And if we look at the class, the created class, you will see the instance creation message that instantiates the class, initialize it, and then you have the value that does the same thing as the method we extracted. If you have questions, let me know. Then we have this, that's all about the struct method. We have this introduce null object. This is a refactoring that replaces all the if nil, if not nil, is nil, if true, is false, and the like, with a kind of null object implementation. You have to have the null object implementation, the null object hierarchy already implemented. But so in this case, address could be nil. So if I come here and I introduce null object, I would say, well, introduce null object on the address instance variable, and it will ask me, okay, what's the null class? I will use not provided address as null class, provided address as a concrete class. And then for each method that the address is referenced with the if nil, if not nil, is nil, if true, whatever, it will ask you what's the polymorphic selector you want to use. So here I think there is an error. So I'm going to put street1. And you can see here that it says address street1, and street1 is implemented as no street in the null class and self street in the not null class. But there is a problem with when you, well, anyway, that's how it works. It's not completely, you have to do more stuff when using it. It's not really a refactoring. But anyway, it allows you to easily create this, to replace all these if nil, if not nil message sends with the new polymorphic message send. There is a move instance variable refactoring. A superclass has an instance variable called street number, so we can move it to a different class. When we do that, you have to select the object that will receive the message to get that object that was stored in the street number instance variable. So I will choose address. No, sorry, made a mistake. Let's go again. Move instance variable. I want to move street number to address. That is an instance of, let's say, provided address. So what we have here is a street number now is accessed through the street number message that now is in address. That is an instance of provided address, and we have the getters and setters for that instance variable. Getter and setters are created only by demand. So if you don't have a setter or a write to that instance variable that you moved, the setter will not be created. And the same thing for the getter. Okay, the guy, this is there is a guy working on this refactoring and also on the move method and struct class, because we want to have the possibility to struct a class from another one. That's why we need the move instance variable and move method. Okay, struct method. When you struct something to a method, it recognizes repetitions, same duplicated code. So if I do a struct method of 100 factorial, I don't know, 100 factorial, it will ask me if I want to replace all the different the repetitions on the same code. I can say yes, only the selection and whatever. I will replace both in this case. If that is repeat it on different method, it will do the same. So 101 factorial, 101 factorial is implemented here and here, two different methods. So it will extract that from both methods. And something new that we added recently is the possibility to rename parameters. So for example, if I want to extract A divided by B, it will tell me, okay, it will suggest the name of the message with A and B, but I can say, I don't know, divide and now dividend by divisor. I'm renaming not only the keyword, but also the parameters. And it will say here, divide A by B, but it will implement the message like divide dividend by divisor. So it changes the name of the parameters. You can change now also the order of the parameters. If I want to extract this A minus B, I can change that to B and A. Okay, so I have to keep the same name of the arguments, but I can put them in different places. So it will send the message keyword 1B, keyword 2A, but it will keep the same method, the same code as before. So you can reorder you can change the order of the parameters. Those are the things for the struct method. We also have inline temporaries. For example, like here, you can inline, in this case, the temporary A. If I come to refactorings, inline temporary, it will replace the implementation, references to A with 99 factorial. And in this case, it realizes that that variable is not used anymore. That's why it removed the variable definition from the method. In this case, it's the two different places. So it will replace the two different places where the temporary variable was used. And here, this is an interesting example of the complexity of this refactoring, because what happens if I want to inline A from the definition of the variable, the declaration of the variable? So if I try to inline it from here, it will tell me there are multiple assignments. I have to select the one I want to replace, to inline. And if I want to inline this assignment, what should it do with this one? So what it does, it only replaces this one, but not this one, as you will see now. Okay, and now if I want to inline this assignment with the instance, with the temporary variable A, it will do it for that one, remove the definition, and so on. Then we have the inline method. We have the implementation of two inline. One is return 20. So if I inline that message send, it will ask me if I want to inline only this message send or all the places where that message is being sent. I will say only this one. And if I want to remove or I want to keep the current implementation, let's say I want to remove it, and then it will ask me the scope of the refactoring, where to look for senders and implementers. Let's say I'm going to do it only in the class. So it will show me the implementation that it will change, and how now we have 20 plus 1. And here is also the inline method, but with different message sends for that method that you want to inline. So let's do it. And now I'm going to say select message sends to inline, and I want to keep the current implementation just for fun. And so I can see the implementer, and also I can see the different places where that message is being sent. And I can say, I can remove this message send, or this message send, I can select the ones that I really want to inline, but let's say I'm gonna inline all of them. And well, it does the inline of the method. And I think that's all. Yeah, that's all I want to show. There are more refactorings to come, but that's what I've been doing in the last couple of months.
Okay, it's very good.
Thank you.
Okay. All right. Thank you very much. Any questions?
So this is only in Faro?
That's Cuis.
Oh, that's Cuis. Sorry.
Yeah.
I should have recognized it. Sorry.
No problem.
I think that also covers the other Peter's question about implementation. Yeah.
Yeah, something I didn't show is how they work with live typing, but I showed that when I showed live typing a year ago, I guess.